What is the best number in the universe? And yet others will respond various other integers. But if you answered any of these things, you're wrong. Let's learn why 1 plus the square root of 5 all over 2, the golden ratio, is a glorious epitome of the beauty of the mathematics that describes our universe, if it isn't already painfully obvious to you. First, let's compute 1 over the golden ratio. That's easy. When we compute the golden ratio itself, it's 1.61803 something. And the golden ratio squared is 2.61803 something. So we see immediately that this is no ordinary number. Now let's do a quick review of basic math. One plus 1 over 1 plus 1 equals 1.5. 1 plus 1 over 1 plus 1 over 1 plus 1 is 1.66666. 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus 1 is 1.625. And since we're lazy, we're going to round all our answers to the nearest one. And then we'll get the famous Fibonacci sequence, which starts with two ones, and each term is the sum of the two previous terms. Some of you might already be familiar with this sequence from your studies in math or from your productive use of time on the internet. But the fact is that the golden ratio is closely tied with the Fibonacci sequence. Maybe these curious mathematical facts don't convince you. That's okay. Let's leave the realm of pencil and paper and look at real life. Suppose that right now on a magical island there are two newborn unicorns and no one else. Unicorns are immortal and always form pairs immediately after being born. On Midsummer's Day every year, each pair that is at least 2 years old will instantly produce two offspring. How many unicorn pairs will there be in n years? In each year you can count how many pairs of unicorns are newborn or less than 1 year old, and how many are at least 1 year old. And then doing this for each year, it's pretty easy to come up with the numbers of unicorns in next year. And if we work this out, we'll find the Fibonacci relation show up nicely. Almost identical mathematical reasoning can be used to show that in a colony of bees, the female to male ratio Consider a rectangle where the ratio of the length to the width is the golden ratio. Now draw a line in it that'll separate it into a square part and a not square part. But you can just as easily experience it by looking at your neighbor's ear. Here's something special about this not square part. Its length is 1 and its width is the golden ratio minus 1, which, as we found out earlier, was 1 over the golden ratio. So that basically means that this not square part is also a rectangle whose length and width are the ratio of the golden ratio. That means we can do the same thing to this rectangle again